Hello everyone, I am Kushal ST and welcome to my channel. In today's video, I am going to be telling you about the unsung heroine of DNA, also known as the Dark Lady of DNA. Her name is Rosalind Franklin. She is a scientist who greatly contributed and found the structure of DNA. Let us know more about her and her contributions and her life story. Let us begin. Rosalind Elise Franklin was born on 25th July 1920 and died on 16th April 1958. She was a British chemist and X-ray crystallographer whose work was central to the understanding of the molecular structures of DNA, deoxyribonucleic acid, RNA, ribonucleic acid, viruses, cold, and graphite. Although her works on cold and viruses were appreciated in her lifetime, Franklin's contribution to the discovery of the structure of DNA were largely unrecognized during her life, for which she was being variously referred to as the wronged heroine, the dark lady of DNA, the forgotten heroine, a feminist icon, and the Sylvia Plath of molecular biology. Name Rosalind Elsley Franklin, born 25th July 1920, Notting Hill, London, England, died 16th April 1958, aged 37, Chelsea, London, England. Resting place Willesden United Synagogue Cemetery. Education St. Paul Girls' School, Alma Mater, Newham College, Cambridge, and University of Cambridge, where she done her PhD. She is known for structure of DNA, fine structure of coal and graphite, and finding out the structures of virus. Scientific career field: physical chemistry, X-ray, crystallography. Institution: British Coal Utilization Research Association. Laboratory Central Desk Services. Chimique de Liet Birkbeck, University of London. King's College London. Thesis: The Physical Chemistry of Solid Organic Colloids, with special references to coal, in 1945. Franklin graduated in 1941 with a degree in natural sciences from Newnham College, Cambridge, and then enrolled for a PhD in physical chemistry under Roland George Crayford Norris, the 1920 chair of physical chemistry at the University of Cambridge. Disappointed by Norris' lack of enthusiasm, she took up a research position under the British Coal Utilization Research Association in 1942. The research on coal helped Franklin earn a PhD waiting from Cambridge in 1945. Moving to Paris in 1947 as a Jacques postdoctoral researcher under Jacques Mering at the Laboratoire Centre des Services Chimiques de Liet. She became an accomplished X-ray crystallographer. After joining King's College London in 1951 as a research associate, Franklin discovered some key properties of DNA which eventually facilitated the correct description of the double helix structure of DNA. Owing to disagreement with the director John Rundle and her colleague Maurice Wilkins, Franklin was compelled to move to Birkbeck College in 1953. Franklin is best known for her work on the X-ray diffraction images of DNA while at King's College London, particularly Photo 51, taken by her student Raymond Gosling, which led to the discovery of the DNA double helix, for which Francis Crick, James Watson, and Maurice Wilkins shared the Nobel Prize in Physiology or Medicine in 1962. In April 2023, scientists, based on new evidence, concluded that Rosalind Franklin was a contributor and equal player in discovery process of DNA, rather than otherwise, as may have been presented subsequently after the time of the discovery. As musical titled Double Helix, based on Franklin's contribution to the discovery, opened on 30 May 2023 at the Bay Street Theatre in Sag Harbor, New York. Watson suggested that Franklin would have ideally been awarded a Nobel Prize in Chemistry along with Wilkins, but although there was not yet a rule against posthumous awards, the Nobel Committee generally did not make posthumous nominations. Working under John Desmond Bernal, Franklin led pioneering work in Birkbeck on the molecular structure of viruses. On the way before she was to unveil the structure of tobacco mosaic virus at an international fair in Brussels, Franklin died of ovarian cancer at the age of 37 in 1958. A team member, Aaron Klug, continued her research, winning the Nobel Prize in Chemistry in 1982. Early life. Franklin was born in 50 Chepstow Villas, Notting Hill, London, into an affluent and influential British Jewish family. Franklin's father, Ellis Archer Franklin, 1894 to 1964, was a politically liberal London merchant banker who taught at the city's working men's college. Mother was Muriel Frances Valley from 1894 to 1976. Rosalind was the elder daughter and the second child in the family of 5 children. Franklin's parents helped settle Jewish refugees from Europe who had escaped the Nazis, particularly those from the Kinder transport. They took in 2 Jewish children to their home. From early childhood, Franklin showed exceptional scholastic abilities. At age 6, she joined her brother Roland at Noland Place School, a private day school in West London. Franklin was 11 when she went to St. Paul's Girls' School in Hammersmith, West London, one of the few girls' schools in London that taught physics and chemistry. At St. Paul's, she excelled in science, Latin, and sports. Franklin also learned German and became fluent in French, a language she would later find useful. She topped her classes and won annual awards. With 6 distinctions, Franklin passed her matriculation in 1938, winning a scholarship for university. The school leaving exhibition of Euro 30 a year for 3 years and Euro 5 from her grandfather. Her father asked her to give the scholarship to a deserving refugee student. Cambridge and World War II. Franklin went to Newnham College, Cambridge in 1938 and studied chemistry within the Natural Sciences tripos. There she met the spectroscopist Bill Price, who worked with her as a laboratory demonstrator and who later became one of her senior colleagues at King's College, London. In 1941, Franklin was awarded second-class honors from her final exams. The distinction was accepted as a bachelor's degree in qualifications for employment. Cambridge began awarding BA and MA degrees to women from 1947, and the previous women graduates retroactively received this. Franklin was awarded a research fellowship at Newnham College, with which she joined the physical chemistry laboratory of the University of Cambridge to work under Ronald George Wilfred Norris, who later won the Nobel Prize in Chemistry. In her 1 year of work there, Franklin did not have much success. Franklin studied the porosity of coal using helium to determine its density. Though, though this, she discovered the relationship between the fine constrictions in the pores of the coal and the permeability of porous space by concluding that substances were expelled in order of molecular size as temperature increased. She helped classify coals and accurately predict their performance for fuel purposes and for production of wartime devices such as gas masks. This work was the basis of Franklin's PhD thesis. The Mehring was an X-ray crystallographer who applied X-ray diffraction to the study of rayon and other amorphous substances. In contrast to the thousands of regular crystals that had been studied by this method for many years, physical chemistry of solid organic colloids with special references to coal, for which the University of Cambridge awarded her a PhD in 1945. It was also the basis of several papers. She published several further papers on this work, which had become part of the mainstream of the physics and chemistry of coal and carbon. Franklin coined the terms graphitizing and non-graphitizing carbon. The coal work was covered in a 1993 monograph and in the regularly published textbook Chemistry and Physics of Carbon. She started working as a research associate in the Medical Research Council's Biophysics Unit, directed by John Randall. She was originally appointed to work on X-ray diffraction of proteins and lipids in solution, but Randall redirected Franklin's work to DNA fibers because of new development in the field, and she was to be the only experienced experimental diffraction researcher at King's at that time. Franklin, now working with Gosling, started to apply her expertise in X-ray diffraction techniques to the structure of DNA. She used a new fine focus X-ray tube and microcamera ordered by Wilkins, but which she refined, adjusted, and focused carefully. Drawing upon her physical chemistry background, a critical innovation Franklin applied was making the camera chamber that could be controlled for its humidity using different saturated salt solutions. When Wilkins inquired about the improved technique, he applied in terms which offended him, as she had an air of cool superiority. With the ingenious humidity controlling camera, Franklin was soon able to produce X-ray images of better quality than those of Wilkins. She immediately discovered that the DNA sample could exist in two forms. At a relative humidity higher than 75%, the DNA fibers became long and thin. When it was drier, it became short and fat. She originally referred to the former as wet and the latter as crystalline. On the structure of the crystalline DNA, Franklin first recorded the analysis in a notebook, which reads: evidence for spiral, meaning helical structure, straight chain, untwisted, is highly improbable. Absence of reflections on meridians in crystalline form suggests spiral structure. An immediate discovery from this was that the phosphate group lies outside of the main DNA chain. Franklin, however, could not make out whether there could be two or three chains. She presented the data at the lecture in November 1951 in King's College London in her lecture notes. Franklin wrote the following: the results suggest a helical structure which must be very closely packed, containing 2, 3, or 4 coaxial nucleic acid chains per helical unit, and having the phosphate group near the outside. Franklin then named A and B respectively for the crystalline and wet forms. The biological functions of ADNA were discovered only 60 years later. Because of the intense personality conflict developing between Franklin and Wilkins, Randall divided the work on DNA. Franklin chose the data-rich A form, while Wilkins selected the B form. By the end of 1951, it became generally accepted that the B DNA was a helix, but after Franklin had recorded an asymmetrical image in May 1952, Franklin became unconvinced that the A DNA was a helix. Franklin was fully committed to experimental data and was sternly against theoretical or model building. As she said, we are not going to speculate. We are going to wait. We are going to let the spots on this photograph tell us what the structure is. The X-ray diffraction pictures, including the landmark photo 51 taken by Gosling at this time, had been called by John Desmond Bernal as amongst the most beautiful X-ray photographs of any substance ever taken. By January 1953, Franklin had reconciled her conflicting data, concluding that both DNA forms had two helices and had started to write a series of pre-draft manuscripts, two of which included a double helical DNA backbone. Franklin's two A DNA manuscripts searched Acta Christianographica in Copenhagen on 6 March 1953, the day before Crick and Watson had completed a model on BDNA. Franklin must have mailed them while the Cambridge team was building their model, and certainly had written them before she knew of their work. On 8 July 1953, Franklin modified one of these in proof ACTA articles in light of recent work by the King's and Cambridge research teams. The third draft paper was on the BDNA dated on 17 March 1953, which was discovered years later amongst the papers by Franklin's Birkbeck colleague Aaron Klug. He then published in 1974 an evaluation of the DAP's close correlation with the third of the original trio of 25th April 1953 Nature DNA articles. Klug designed this paper to complement the first article he had written in 1968, defending Franklin's significant contribution to DNA structure. Klug had written this first article in response to the incomplete picture of Franklin's work depicted in James Watson 1968 memoir, The Double Helix. Particular, this model was the phosphate backbone of the model building had been applied successfully in the elucidation of structure of the alpha helix by Linus Pauling in 1951. But Franklin was opposed to prematurely building theoretical models until sufficient data were obtained to properly guide the model building. She took the view that building a model was to be undertaken only after enough of the structure was known, molecules forming a central core, but Franklin pointed but that the progressive solubility of DNA crystals in water meant that the strongly hydrophilic phosphate groups were likely to be on the outside of the structure, while the experimental failure to titrate the Co and NH2 groups of the bases meant that these were more likely to be inaccessible in the interior of the structure. The essential setback led Watson and Critic to focus on other topics for most of the next year. 6 weeks of intense efforts followed as they tried to guess how the nucleotide bases pack into the core of the DNA structure within the broad parameters set by the experimental data from the team at King's that the structure could contain one or more helices with a repeat distance of 34 angstrom, with probable 10 elements in each repeat, and that the hydrophilic phosphate groups should be on the outside. Though as Watson and Crick struggled to come up with a structure at that time, departed from each of these assumptions during the process. Crick and Watson received a further impetus in the middle of February 1953 when Crick's thesis advisor Max Perutz gave Crick a copy of a report written for a medical research council by a physics committee visit to King's in December 1952, containing many of Franklin's crystallographic calculations. This decisively confirmed the 34 angstrom repeat distance and established that the structure had C2 symmetry, immediately confirming to Crick that it must contain an equal number of parallel and antiparallel strands running in opposite directions. Watson and Crick finished building their model on 7th March 1953, a day before they received a letter from Wilkins stating that Franklin was finally leaving and they could put all hands to the pump. This was also one day after Franklin's two A DNA papers had reached Acta Christianopica. Wilkins came to see the model the following week, according to Franklin's biographer Brenda Maddox. On 12th March, and allegedly informed Gosling on his return to King's One of the most critical and overlooked moments in DNA research was now and when Franklin realized that considered that the DNA was a double helical molecule. When Clark first examined Franklin's document after her death, she initially came to an impression that Franklin was not convinced of the double helical nature until the knowledge of the Cambridge model. But Clark later discovered the original draft of the manuscript, dated 17 March 1953, from which it became clear that Franklin had already resolved the correct structure. The news of Watson and Crick model reached King's the next day, 18th March, suggesting that Franklin would have learned of it much later since she had moved to Birkbeck. Further scrutiny of her notebook revealed that Franklin had already thought of the helical structure for BDNA in February 1953, but was not sure of the number of strands. As she wrote, evidence for two chain or chain. Eric's conclusion on the helical nature was evident, though she failed to understand the complete organization of the DNA strands, as the possibility of two strands running in opposite direction did not occur to her. She is reported to have commented, "It's very pretty, but now I am but how they are going to prove it." As an experimental scientist, Franklin seems to have seen interested in producing far greater evidence before publishing as proven and proposed model. As a result of a deal struck by the two laboratory directors in April 2023, scientists based on new evidence concluded that Rosalind Franklin was a contributor and equal player in the discovery process of DNA, rather than otherwise, as may have been presented subsequently after the time of the discovery. A musical title, Double Helix, based on Franklin's contribution to the discovery, opened on 30 May 2023 at the Bay Street Theatre in New York. RNA research. Franklin continued to explore another major nucleic acid, RNA, a molecule equally central to life as DNA. She again used X-ray crystallography to study the structure of the tobacco mosaic virus. And RNA virus, a meeting with Aaron King in early 1954 led to a long-standing and successful collaboration. In 1953, Franklin published their first major works on tobacco mosaic virus in Nature, where she described that all tobacco mosaic virus articles were of the same length. This was in direct contradiction to the ideas of the eminent virologist Norman Peary, though Franklin's observation ultimately proved correct. Franklin's research grant from ARC expired at the end of 1957, and she was never given the full salary proposed by Birkbeck. After Bernard requested ARC chairman Lord Rothschild, she was given a one-year extension ending in March 1958. Expo 58, the first major international fair after World War II, was to be held in Brussels in 1958. Franklin was invited to make a 5-foot-high model of TMV, which she started in 1957. Her materials included table tennis balls and plastic bicycle handlebar grips. The Brussels World Fair, with an exhibit of her virus model at the International Science Pavilion, opened on 17th April, one day after she died. In her grant application, Franklin mentioned her new interest in animal virus research. She obtained Bernard's consent in July 1957, though serious concerns were raised after Franklin's disclosed her intentions to research live instead of killed poliovirus at acting. Birkbeck eventually Bernard arranged for the virus to be safely stored at the London School of Hygiene and Tropical Medicine during the group's research. With her group, Franklin then commenced deciphering the structure of the poliovirus while it was in a crystalline state. She attempted to mount the virus crystals in capillary tubes for X-ray studies, but was forced to end her work due to her rapidly failing health. After Franklin's death, Clark succeeded her as group leader, and he, Finch, and Holmes continued researching the structure of the poliovirus. They eventually succeeded in obtaining extremely detailed X-ray images of the virus. Personal life. Franklin was best described as an agonist. Her lack of religious faith apparently did not stem from anyone's influence, rather from her own line of thinking. She developed her skepticism as a child. Her mother recalled that she refused to believe in the existence of God and remarked, "Well, anyhow, how do you know he isn't she?" She later made her position clear, now based on her scientific experience, and wrote to her father in 1940. Science and everyday life cannot be and should not be separated. Science for me gives a partial explanation of life. I do not accept your definition of faith, that is, belief in life after death. Your faith rests on the future of yourself and others as individuals. Mine is in the future and faith of our successors. It seems to me that yours is the more selfish. The question of a creator of what? I see no reason to believe that a creator of protoplasm or primeval matter, if such there be, has any reason to be interested in an insignificant race in a tiny corner of the universe. However, Franklin did not abandon Jewish traditions. As the only Jewish student at Lindore School, she had Hebrew lessons on her own while her friends went to church. She joined the Jewish Society, were in her first team at Cambridge. Out of respect of her grandfather's request, Franklin confided to her sister that she was always consciously a Jew. Franklin, Franklin also loved traveling abroad, particularly trekking. In his book, The Double Helix, Watson provides his first-person account of the search for and discovery of the DNA. He paints a sympathetic but sometimes critical portrait of Franklin. He praises her intellect and scientific acumen, but portrays Franklin as difficult to work with and careless with her appearance. After introducing her in the book as Rosalind, he writes that he and his male colleagues usually refer to her as Rosie, the name people at King's College London used behind her back. William Ginoza of the University of California, Los Angeles, later recalled that Franklin was the opposite of Watson's description of her. And as Maddox comments, Americans enjoyed her sunny side. Illness, death, and burial. In mid 1956, while on the work relative to the United States, Franklin first began to suspect a health problem. While in New York, she found difficulty in zipping her skirt. Her stomach had bulged. Back in London, Franklin consulted Mayor Livingstone, who asked her, "You are not pregnant?" To which she retorted, "I wish I were." Her case was marked urgent. An operation on 4th September of the same year relieved two tumors in her abdomen. After this period and other periods of hospitalization, Franklin spent time convalescing with various friends and family members. Franklin chose not to stay with her parents because her mother's uncontrollable grief and crying upset her too much. Even while undergoing cancer treatment, Franklin continued to work, and her group continued to produce results. 7 papers in 1956 and 6 more in 1957. At the end of 1957, Franklin again fell ill and she was admitted to the Royal Marsden Hospital on 2nd December. Franklin returned to work in January 1958 and was also given a promotion to research associate in biophysics. On 25th February, she fell ill again. On 30th March, died a few weeks later, on 16th April 1958, in Chelsea, London, of bronchopneumonia, secondary carcinomatosis, and ovarian cancer. Exposure to X-ray radiation is sometimes considered to be a possible factor in Franklin's illness. Other members of her family have died of cancer, and the incidence of gynecological cancer is known to be disproportionately high among Ashkenazi Jews. Posthumous recognition. In 1982, Lota Sigma Pi designated Franklin a national honorary member. In 1984, St. Paul's Girls' School established the Rosalind Franklin Technology Center. In this picture, you can see that mural inscription on King's College London, Franklin Wilkins Building, co-named in honor of Rosalind Franklin's work. In 1992, English Heritage placed a blue plaque commemorating Franklin on the building in Drayton's Garden, London, where she lived until her death. In 1993, King's College London renamed the Orchard residence at its Hampstead campus as Rosalind Franklin Hall. In 1993, King's College London placed a blue plaque on its outside wall bearing the inscription R.E. Franklin, J.G. Rosling, A.R. Stokes, M.H.F. Wilkins, H.R. Wilson, King's College London, DNA X-ray Diffraction Studies, 1953. In 1995, Newnham College, Cambridge opened a graduate residence named the Rosalind Franklin Building and put a bust of her in its garden. In 1997, Birkbeck University of London School of Crystallography opened the Rosalind Franklin Laboratory. In 1997, a newly discovered asteroid was named 9241 Rose Franklin. In 1998, National Portrait Gallery in London added Rosalind Franklin's portrait next to those of Francis Crick, James Watson, and Maurice Wilkins. In 2002, the University of Groningen, supported by the European Union, launched the Rosalind Franklin Fellowship to encourage women researchers to become full university professors. In 2003, the Royal Society established the Rosalind Franklin Award, officially the Royal Society Rosalind Franklin Award, a lecture for an outstanding contribution to any area of natural science, engineering, or technology. In 2003, the Royal Society of Chemistry declared King's College London as National Historic Chemical Landmark. In 2013, Google honored Rosalind Franklin with a doodle showing her grazing at a double helix structure of DNA with an X-ray photo of photo 55 beyond it. In 2019, the European Space Agency named its ExoMars rover Rosalind Franklin. In 2019, the University of Portsmouth announced that it changed the name James Watson Halls to Rosalind Franklin Halls from 2nd September. In 2020, Franklin was selected for the Time 100 Women of the Year for 1953. On 30 June 2021, a satellite named after her, NewSat 19 or Rosalind COSPAR 2021 059 AC, was launched into space. Science and everyday life cannot and should not be separated. By Rosalind Franklin. The most inspiring thing about Rosalind Franklin is that though she was suffering from cancer, she never gave up. She never gave up working. There were many ups and downs in her life, but she never gave up. She continued to work with full dedication and contributed her work to the entire world. She is truly a role model to every woman to be independent, and they are no less than men. Thank you, Rosalind Franklin, ma'am, for everything. If you like my video, then please do subscribe to my channel and support me. Thank you, everyone, for watching.